Huh. Good. Share that.
Metals are conductive, can conduct heat, electricity, because
Mm-hmm.
they have
Mm-hmm.
free electrons, which while
Mm-hmm.
non-metals are most of the time, while non-metals are most of the time less what do you call it, have a low melting point and
Mm-hmm.
are not
Mm-hmm.
can conduct heat and electricity.
Mm-hmm. Good. Good. That's, now these are the physical
Metal
properties. Huh. Good. Uh-huh. Say that.
Metals, when reacting with acid, they produce hydrogen and salt. When metal react with when non-metal react with bases, they produce. When metal carbonates react with acids, they produce hydrogen carbonate and the salt. When they and there are few methods of electric refining. The way we
Mm-hmm.
refine metals from ores, it is roasting, calcination,
Mm-hmm.
electrolytic refining.
Mm-hmm.
Electrolytic refining is the way we refine metal ores, which are highly what do you call, reactive,
Highly
such
reactive.
as
Mm-hmm.
sodium, potassium.
Mm-hmm.
While
Mm-hmm.
for others you use calcination or roasting, where you heat the metal with or without oxygen.
Mm-hmm. Okay, fine. Good. Right. So you discussed some of the physical properties, some of the chemical reactions, with the metals and the non-metals of other reactants, and then you were discussing about the metallurgical parts. Fine. Good. Excellent. Let's come to the basics quickly. Fine. What is it that metals and non-metals, basically, what is the basic point of difference between metals and non-metals? First of all, what category are metals and non-metals a part of? Can I say these are elements? Can I say these are elements?
Yeah,
Elements basically have been categorized into three categories: metals, non-metals, and
metalloids.
metalloids. Yes, that's the point. Fine. Now, what are elements? Very quickly, what are elements?
Elements are single atoms,
Single atoms. Okay, basically, a
like
group of
one one type
single
of.
type of atom. Yes, one type of atom. Fine. One type of atom, we get elements. Fine. So metals and non-metals basically are at elements. Okay. When we talk about elements, can I say that all of their atoms will be same? All of their atoms will be same. So ultimately,
Yeah,
everything that we're talking about is ultimately made from the atom. Is ultimately made from the atom. Fine. So my
yeah,
point is, let's talk about the atomic level. What is the difference between metals and non-metals at the atomic level? The basic difference which is giving them these different opposite antagonistic properties.
yeah,
Mhm. Let's take a very quick example. Okay. So basically, we are saying metals in class 9. We actually learned that metals and non-metals are both of them type of elements, but they are having different properties. There are some set of properties which metals have, and therefore they are called as metals. And other elements which do not have those properties, we call them as non-metals, right? Example,
yeah,
we are saying that metals are good conductors of heat and electricity, whereas non-metals generally are not good conductors of heat and electricity. Therefore, we have categorized them as metals and the other one is non-metals, right? This is a simple point.
mm,
My,
yeah.
my question is, what I want to discuss here is that what is it at the atomic level that is giving them these different properties, almost opposite to each other? Hmm.
Like the number of electrons in the last.
Uh-huh. Good, excellent. Number of electrons in the last shell. What is the last shell called as the valence shell, right? So can I
Yeah,
say it is somewhere the electronic configuration, right? Electronic configuration is what the arrangement of electrons in the shells. And when we talk
yeah.
about the last shell, when we talk about the valence shell, metals, what is the behavior shown by metals and what is the behavior shown by non-metals?
Metals lose electrons, non-metals gain electrons.
Metals lose electron and non-metals they gain electron. And when metals lose electron, the atoms becomes the ion and they generally form the cations because they gain positive charge. Hmm. And when non-metals, when they lose the when they gain the electrons, they form what kind of ions? The anions and with the negative charge, right? This is one of the basic difference between the properties of metals and non-metals. You can clearly see that they are having opposite behavior, opposite natures, opposite reactions right here because of this one difference here. So can we quickly take one example here of metals and non-metals? Example of metals:
Ferrous, iron,
sodium, potassium, iron, calcium, magnesium, aluminium, zinc, copper. Yes, all of these are metals.
yes,
Gold, silver, platinum, all of these are metals. Although they are very inert, almost unreactive, but they are metals, right? They are metals.
yeah,
Now come to the non-metals. What are some of the examples of non-metals?
oxygen,
Mm-hmm.
argon, helium,
Mm-hmm.
then carbon,
Phosphorus, sulfur, right? Chlorine, fluorine, iodine, bromine. Okay, all of these are examples of non-metals, right?
yeah,
So
lead
this
is,
is some of the
lead is,
manganese is a metal,
no, lead,
lead is a metal, nickel is a metal, tin is a metal. Okay, so all of these are metal. Okay, fine.
tin is
Now
SN,
SN is tin.
okay,
SN is tin. Okay, fine. So coming on to the next one. So quickly going through the NCRT here. Be just a second. So that way. See, my point is very clear. We'll be sticking strictly to the NCRT here. Fine.
yeah,
So we'll be discussing and then we'll be coming back to the NCRT so that we are able to understand the language of the NCRT. Fine. So I'll be starting with the physical properties, but then before that, any problem, any confusion? Fine. Now, what are physical properties? What are physical properties?
like the properties we can see by our eyes
Yeah.
or
Basically,
observations.
the properties which are not based on the chemical reactions, right? The properties which are not really based on the chemical reaction, because those properties are the chemical properties. Fine. So coming on to the physical properties.
Ma'am, can I have my charger?
Yes, yes, sure. Physical properties. Okay. So we'll be having a table here, metals and non-metals. See, before discussing these, I would advise you one thing. I would want to tell you one thing, and that is, whenever we are discussing the properties, okay, we always use this phrase which is generally, because there are some or many exceptions. Therefore, we can never use it all of the metals or for all of the non-metals. Okay, so we will always say generally, generally, and generally. Example: generally, metals are good conductors of heat and electricity. Generally, metals are solid at room temperature. Generally, non-metals are not lustrous. Okay, because there are exceptions present. Fine, fine. So,
Yeah,
what are some of the properties? Can you start with some of the physical properties? Let's start with the state. Generally, metals are
good heat,
solid at room temperature. Huh? Solid at room temperature. Why are we specifically measuring the state at physical temperature?
what?
Hmm. Why are we specifically measuring the physical state at room temperature?
I don't understand.
We are saying the
The voice
physical
is
state is solid here. The physical state is solid here.
yeah,
Why I'm asking is that what I'm asking is that why are we taking the physical state at room temperature only?
Because
Mm-hmm. Yes, बच्चे.
because the room temperature is the general temperature everywhere.
We see every matter could be in the physical solid or the liquid state. They have different temperatures at which they'll be changing to the solid, liquid, or gaseous state. So basically, that's right. Your answer is right. We need to have one temperature or a range of temperature at which we can measure the physical state, right? And that we have taken as the room temperature. Excellent. And what's the room temperature? Can you tell me the value of the room temperature that we take it as?
It's like 27 to 33,
20?
7.
Yes, that's right. 27. Basically, 25 to 20, 27 degrees Celsius, we take it as, right? The room temperature. So, if I talk about 25, 27 degrees Celsius, what is the value in Kelvin? 300 Kelvin?
Yeah,
Okay, fine. Now come to the non-metals. Come to the non-metals. We'll be discussing all the exceptions after discussing the properties. Okay. So what in non-metals? What is the physical state? Are they solid?
they are
Huh.
they
Generally,
vary. Ma'am, they vary.
yeah.
Some are gas and some are in the solid
So
state.
can we write generally not solid at room temperature? Simple.
Okay,
Yes.
but there are solids, right?
But there are. Just give me 1 second. I can just plug in my charger. Yes. Sorry.
Shouldn't it be generally not liquid at room temperature?
Not liquid, not solid at not solid and liquid at room temperature. They're generally in the gaseous form. We just have one this thing, or one non-metal which is liquid at room temperature, and few of the non-metals in the elemental form which are actually solid. Example, graphite and diamond. Yes.
What?
Am I not clearly audible to you?
Oh, you're lagging a lot, and
Okay.
also the voice is very low.
The network problem. Fine. What I'm saying is that generally all the non-metals are mostly they are present in the gaseous state. There's one non-metal which
Yeah,
is present in the liquid state, right? And there are some of the non-metals in the elemental form, example diamond and graphite, which are actually present in the solid form.
yeah.
Yeah. So basically, we are just writing here in the contrary, in as a property to the contrary of the metals. They are solid at room
Okay.
temperature generally.
So no,
Generally,
I
non-metals.
actually write that as I
You can
actually write
write
it
it
as generally liquid,
generally.
not liquid.
That is also fine. Generally, not liquid. But then, are you saying they could be solids generally, right?
They could be solid or gas.
Are they really solid mostly?
They're mostly gaseous.
Yeah, they are mostly gaseous. That's what I'm saying. So I'm saying, bache, listen. What I'm saying is that if you write generally not liquid at room temperature, okay. If you write it as
Yeah,
generally not liquid at room temperature, don't you think that is indicating that generally they could either be gaseous or solid at room temperature, which is also not very true.
yeah.
Okay. So the best is to write generally not solid or liquid at room temperature.
Okay.
Is that clear to you? Any confusion here now?
No.
No. Fine. The third one, the second one,
So
the second, yes.
we can simply write it as generally gaseous at room
You can
temperature,
write
right?
it generally gaseous at room temperature. You can write it like that. Generally gaseous at room temperature. Okay. In
Yeah.
whatever manner you are saying, you know that the physical state basically is more of the gaseous state for the non-metals. Fine. Coming to the next property. If the metals are generally solid at room temperature, if the metals are generally solid at room temperature, it is very obvious that they will be rigid and they'll be hard. Okay, and they'll be having higher
Yeah.
density. Yes. Can I write generally
Yes.
hard? Correct. Generally hard and have high density. And what will be the point here
Yeah.
with non-metals? Now see,
Generally have very low density.
generally,
Have very low density.
and for hardness, what will be the point for hardness? See, that's what I'm telling you
Yeah.
here. See, hardness is one thing, softness is another thing, and being brittle is another thing. Non-metals are generally brittle. What do we mean by brittle? See, let's suppose I have a rock, a piece of rock, okay, that we know is hard. We cannot really press it really, okay? Are you getting it? Now, clay, if
Yeah.
you have seen, that is soft. Clay is soft, right? You
Yeah.
can just press it and squeeze it, its shape will change.
Yeah.
But if you take a very small, this thing pebble, and if you press it like that, don't you think it will change to the powdered form or chalk? If you press it, if you put some force against it, don't you think it will change to the
Yeah.
powdered form? That is being called as brittle. That is being called as brittle. Okay. So non-metals, they are generally
Yeah.
brittle. Are generally
Gas is, how can gas be brittle, man?
how can be?
How can gas
We
be
are
brittle?
saying when we are talking at the room temperature, the state when we are talking about the state that is at the gaseous in the gaseous state, right? Let's suppose when we have solidified them, that is when we are talking about the brittle or the hardness parts.
Can we solidify oxygen, hydrogen, and stuff?
Yeah, we can, but at a very, 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 very low temperature.
Okay.
And there are some, this thing, non-metals which are existing in the solid state. So they
Yeah.
are not showing
Sounds
the
fair.
properties. Yeah, they are not showing the properties of being very hard like that. If the force is there, they will. Had they been hard, they would actually show malleability and ductility also.
Mm. Yeah.
Are you getting it?
Yes, man.
Brittle. So basically, what I'm telling you here is that metals will be hard, generally hard, and some the non-metals will generally be brittle. And the reason I'm writing here this these 2 points, hard and brittle, is that because there are some metals which are also soft, okay, which are not hard, but rather they are soft. They are solid, but soft solids. They are solids, but soft solids. And the examples are the sodium, the potassium, the lithium. Okay, all of these are very soft metals. You can cut them very easily with a knife.
Yeah.
That is how soft they are. Okay, that's it. Now, the next property. What else could be the next property for metals and non-metals?
Have a very high melting and boiling point.
Yes. So generally, since obviously, these are all the properties linked to the solid state. If the solid state is there, generally the melting point and the boiling point will be high, right? Yes. What will be the point for the gaseous state? I mean, the non-metals? The boiling point and the melting point will generally be on the lower side. Yes.
Yeah. Yes.
Fine. Let's come to the next point. What else? The properties for metals and non-metals?
Good conductors of electricity and heat.
Good conductors of electricity. Okay. For the generally, again, there are exceptions, huh? Non-metals, are they insulators?
Yeah.
They are not insulators. We will use the term not good conductors. Okay.
Except for graphite.
Yes. Graphite is a good conductor of. Graphite is a good conductor of electricity or heat or both of it?
Electricity. Electricity.
Electricity.
Electricity.
Yes, yes, electricity. Next point, very important. Can we write that one of the major characteristic property of the metals is that they show malleability and ductility?
Yeah.
Yeah. What is the reason of the metals being malleable and ductile?
Because they are very hard.
Next one,
Have the ability to lose electrons.
what? They are sonorous, they are lustrous, huh? Non-metals are generally not sonorous, generally not lustrous.
Yeah.
Huh. What else?
That's all right.
Metals generally are not present in a very wide range of colors. Metals generally are not present in a very wide range of colors. They are generally present in that range, which is like grayish, silverish, or yellowish, goldenish. Okay, in that range. Whereas non-metals, they tend to have a wide range of colors that they will possess. Okay, so fine. Any other point here? Any other point regarding the properties of metals and non-metals? Now come to the exceptions part. Hmm. We start from the beginning. First point, the metals and non-metals, the metals are generally solid at room temperature. What is the exception for that?
Mercury, bromine. Mercury, bromine.
Excellent. Mercury, which is a metal, okay, is liquid at room temperature. At what temperature will it solidify? Any idea? Around that is around minus 38.8. So we'll write it as minus 39 point well, minus 39 degrees Celsius. Okay. This is the temperature at which it solidifies. Where are you from?
Yeah.
Where are you from, Umer?
Sri Lanka.
Sri Lanka. Great. Where are you right now?
Oman.
Fine. The next, bromine, which is a non-metal, is liquid. Huh? Is
Yeah.
liquid at room temperature. Acha, tell me two
Yes.
elements which are actually liquid at room temperature. Two elements I'm saying. Two elements.
Mercury and bromine.
Mercury and bromine. Fine.
Bromine.
And if I say just tell me one metal which is solid liquid at room temperature,
Mercury.
mercury. Fine. Next point, exception. Next point, what is the second point that we have written there? Generally hard. I told you. What are the metals which are generally not hard? Hmm.
Sodium, potassium.
Sodium, potassium. What is the symbol for sodium?
Na.
Na. For potassium,
K.
K. Lithium, gallium, all these are some of the metals which are very soft. Which are very soft. Again, they are solid, but they are soft. Okay, they are solid, but they are soft.
Yeah.
Come to the non-metals part. Any element, I mean, any non-metal which is hard. Exception,
Diamond.
diamond. is the naturally hardest occurring substance, right? What non-metal is diamond made up of?
Diamond is made up of carbon.
Ah, next point. High melting point and boiling point. What is the reason of having high melting and boiling point?
Yeah, because
Huh.
they are able to conduct heat.
They,
Are able to conduct heat
why are they able to conduct heat?
because they have strong interatomic force.
Yeah. So basically, when we were in the ninth class, we learned the particles in case of the solid state are generally very close to each other. And therefore, if we need to
Yeah,
separate them, we need high amounts of energy. Therefore, the solids generally have high, melting point. And we are clearly seeing that the metals are generally solid at room temperature. Yes. So they'll be needing high amounts of energy. Yes. Now, tell me an exception to the high melting and the boiling point of metals.
mercury
Mercury. Why? Excellent.
because it has a very low
Mm,
boiling point.
yes. Yes. And can you tell
Melting
me any
point.
other metal which will be having, lower melting boiling points? You know it. We had just now talked about it. Gallium, potassium, all of these
Yeah,
metals, they are very soft, right? So don't you think they'll be having somewhat lower melting boiling points? I can specifically talk about gallium,
yeah,
which can actually melt in the hand. So its melting point is around 303 Kelvin, which is very low, right? Which is very low if you see.
yeah.
Now, come to the non-metals part. Any non-metal which will have a high melting point?
Diamond should have a low melting point.
Excellent. Diamond and graphite. Diamond and graphite. Fine. Now,
Yeah,
which is the most malleable metal if we talk about the malleability and the conductivity? Which is the most malleable metal?
gold,
Gold. And let's talk about the conductivity of electricity and heat, which is the best conductor of electricity
copper,
in case of metal.
copper.
Silver. Ag. Okay. Silver is the best conductor of electricity. But why don't we use the silver wires then? Why do we use the copper wire?
Because it's expensive and rare.
Because,
Expensive and rare.
yeah, fine. So, any metal which is any non-metal which is not lustrous,
Potassium,
non-metal which is not lustrous,
non-metal,
non-metal which is lustrous, non-metal which is lustrous, non-metal which is lustrous. That is opposite to the properties of generally the non-metals, right? They are not lustrous.
yeah,
Which non-metal is it? It's the iodine. Okay, it's the iodine. Fine. Any other exception? Graphite is a very good conductor of electricity that we have already discussed. Graphite is a very good conductor of electricity. Fine. Now, what are allotropes? What are allotropes?
I don't know.
Hmm? We have this term in class in NCRT. Okay, that is allotrope. See,
Uh-huh.
diamond, graphite are allotropes to each other. Are
That means
of carbon. I'm coming to that. I'm coming to that. Okay. Are allotropes of carbon. Let's quickly understand what this is. We know that both carbon and diamond are made up of carbon atoms, right? Both diamond and graphite, both of them are made up of carbon atoms. And both of
yeah.
them are solid. And both of them are solid. Okay. So allotropes basically mean different structures but in the same state made up of the same atom. They are the allotropes to each other of carbon. Example, let's say that diamond is made like this. All of these are carbon atoms. I'm just giving you an example here. Okay. Graphite is made like this. Okay. Both of them are solids. Both of them are made up of carbon atoms. But what is different? The structure is different, right? The bonding is different. Are you getting it? Therefore,
Yes.
has got carbon has three allotropes: diamond, graphite, and fullerene.
Just because it has a different structure, does it get a different color also?
Does it get a different color?
Yeah.
What, no, I'm asking you. What are you asking?
Like just because they have a different structure, they get different
Yes,
color
yes.
and different.
They have a yes. Or see, the properties would also differ because then everything changes. You know, if the number of atoms are changing, then hybridization and everything will change. The properties will differ. Okay, the bonding is completely different. The
Okay.
bonding is completely different for diamond and graphite. Fine, but both of them are in the solid state. Are both of them in the solid state? Yes, both of them are in the solid state. Okay,
Yes.
both of them are made up of the same carbon atom, bonded differently. Fine.
Mm.
Any problem in the
Yes.
allotrope part?
No. No.
Quickly coming back to the NCRT, I would quickly want to go to the allotropic part here. Why are metals able to conduct electricity?
Because they lose electrons. They have
Metals
free
have
electrons.
free, yes, metals have free electrons. Good. See, carbon is a nonmetal that exists in different forms. Each form is an allotrope. Diamond, an allotrope of carbon, is the hardest natural substance known and has a very high melting and boiling point. Graphite, another allotrope
Mm.
of carbon, is a conductor of electricity. Fine.